Good day guys, welcome to our first video on basic inverter design. In this video I'm going to talk about how to design an inverter, the different types of inverter, the sine wave, how inverter works. So before that, let's look at the scheme we have for this basic inverter design. First of all, we are going to see the DC current, the AC current, the frequency, the signal, and the topology. What do I mean by all these things that are listed here? We're going to see the difference between the DC and AC, how this inverter converts DC current into AC current, and we are going to see another major role this frequency plays in an inverter. In this frequency, we have duty cycle. We will see what effects the duty cycle does in an inverter. Then the signal, we talk about different signal that we have: the square wave signal, the modified wave signal, the pure sine wave signal, and how we can achieve those signal. Then another one we are going to see is the topology. I'm going to cover all this in a separate video, but today's video I'm going to do the basic tutorial to see how an inverter works. So in this topology, we are going to see the push-pull topology, the full bridge topology, the half bridge topology, the H bridge topology, and other things in an inverter, and how we can design it from scratch. So without wasting much of your time, let's go into what we have today. So let's see how this inverter works. If this is for an inverter, mostly the load we use in our home these days works in AC current. What do we mean by AC current? AC simply means alternating current. If you look the dictionary of if you look for the full meaning of alternating current, you will see that it's something that changes its state. So that is basically what an AC is. An AC is what changes from its original state, changes from positive to negative, from negative to positive. So, and most of the load that we use in our home, most of our appliances works in this AC. And how can this inverter convert a direct current that only moves in a one direction? How can this inverter convert this direct current into an AC? So in this video we are going to see how it does that. So this is just a simple diagram of an inverter, how it converts a DC direct current into an AC alternative current. So looking at let me break it down. If you use an oscilloscope to view this DC signal, this is the 0 point, this is your minus voltage, this is your positive voltage. Once you apply a DC current into an oscilloscope, you'll see this DC current is just at its peak. Its peak means the maximum voltage being applied to it. It can be 12 volts, it can be 24 volts, depending on the voltage you apply. So this is the DC signal. Then when you come to an AC signal, this is an AC signal. It changes its state from positive to negative. So I use this square wave to show you how this AC current changes its state with this help of graph. So this is the 0 point, this is the positive volts, negative volts. So monitoring this AC current, you see that it will go from this positive voltage down to this middle point, down to negative voltage, upwards. That is the behavior of an AC current. It changes its state from positive to negative, from positive to negative. Okay, so then let's talk about since I've explained about this DC current and AC current, let's see what is frequency, what important role frequency plays in an inverter, and also the duty cycle. So when we talk about frequency, we are talking about how many cycles. So this is just a one cycle. This is an AC voltage, and we say that AC changes is an alternative current. That means from positive to negative. Using the help of this graph, you see this is the 0 point. So Once an AC changes its position per cycle, it is known as 1 Hz. By me looking at this thing, you can see that this thing changes. This is the signal of an AC. So this is the starting point of this signal, and it will also end here, which completes 1 cycle, and this 1 cycle is what we call 1 Hz. So if you have so many of these things, this signal, like up to 20, you know it is 20 Hz. Just like this one that I drew here, this is the first cycle. Don't mind the way I drew this thing. This is the first cycle, 1 Hz, another cycle, 2 Hz. So that means this signal is 2 Hz, 2 Hz signal, which is the frequency. And then let's talk about the duty cycle. I'm just trying to explain it. We have not go in depth on how inverter work. I'm just trying to explain the basic of AC, DC, and the frequency, the important role they play in an inverter. So this is what we call about. This is what we say about duty cycle. The duty cycle simply means the percentage of the on time versus the off time. Just like the way I drew this signal, I'm just using a square wave, but this is applicable to not any wave. It can be sine wave, it can be modified wave. So this is the on time, this is the off time, and the space between the on time and the off time is what we call the duty cycle. Okay, so this on time is 80% on and 20% off. So if we are asked to define this thing, the frequency of this signal and the duty cycle of this signal, we can say this is a 4 Hz frequency, because it produces a 4 signal, 1, 2, 3, 4, which is 4 Hz. And if we are asked to about the duty cycle, we can say that the duty cycle is 80%, because the on time is 80% on and the off time is 20% off. So that is why I wrote T on 80%, T off 20%. So let's look at another signal. Once we decrease the duty cycle, this is 30% duty cycle. The on time is 30% on, while the off time is 70% on. This also affects the voltage that an inverter produces. The output voltage also depends on the duty cycle. Once the duty cycle is high, the output voltage is increased, and once the duty cycle is decreased, the output voltage is also decreased. So that is an important that is where the duty cycle comes in an inverter. So since you can be able to understand what we mean by frequency, the duty cycle, and the important role they play in an inverter, it is a huge bonus for a beginner. So let's see how this inverter works. Basically, we know that all the appliances that we use in our house operate in AC current, which is alternative current. So how do this inverter convert this direct current into an AC current? And for our appliances to operate, it must sense an alternating current, a changing current, before it can operate. So let me show you the basic way this inverter convert this DC into an alternative current. This is our load, and we have 4 switches here: switch 1, switch 2, switch 3, switch 4, and this is the positive current of the DC, and this is the negative current of the DC. So let's see how this thing will operate as an. So if you press this first switch, this switch 1, and press this switch 4, you will see that this terminal will become positive, while here will become negative. Then current will flow from this junction to this place, back to the negative side. Then once you release this switch 1 and switch 4, you press this switch 2 and switch 3. Here will become positive, here will become negative. Then current will flow from this direction to here, back to the negative. You will see that this load is receiving an alternative current based on the way the current is flowing. So Look at this thing now. If you press here and press here, this is one cycle of the AC signal. The current will flow here back to the negative, half cycle. Then once you release this one and press here and press here, once the polarity changes, the other cycle will complete, which will be 1 Hz. And we know that we human beings are not that fast enough to control this thing like that. So that's why we need an external signal that can be able to control this thing. And this switch will be replaced by the MOSFET, the FET, either IGBT or MOSFET or transistor, because transistors are really fast in switching. So, but in our next video, I will show you how to do that, how we can use MOSFET to replace this switch. But this is just the simple knowledge, the basic knowledge on how this inverter converts this DC. If you look at this DC, you see that this DC is the source of this, the whole this is the source. So the way the switching, the way this thing switches is how the DC is being converted to AC. Okay, so and we human beings, we are not that fast enough to control this switch like that up to 50 times, which is 50 Hz. Because this load does not need to see that it as in it you need to switch this switch fast enough so that this load will not notice anything that the current is changing. It will be fast enough, because if you slow it down, you might not be able to. You will see that this load will be flickering. If it is a lamp, you will see that it will be on and off. But if you do it really fast, you will not notice the changes. You will just see it steady on, because it is very fast. And we human beings, we are not that fast enough to do that. That's why we need a MOSFET that is fast in switching and a signal that will control it. So in our next video, I will be showing you that. So make sure you like this video, share it. The amount of likes that I will get in this video will also motivate me to do more. So make sure you like this video, share it, subscribe to my channel, because there are many things that we are going to do in this channel. So thank you guys for watching. Please stay tuned. Don't forget to like, share and subscribe to my channel. Thank you.